Yes, I started the live. Please start.
Okay. Okay. So, hello everyone. Good evening. Welcome to this live session of this course, Variational Calculus and their applications. Uh, First, let me start with introducing myself. My name is Diksha Bansal, and I'm a TA in this course in NPTEL. And if I want to talk about my education, I'm currently in my final year of my PhD, and I'm pursuing my PhD from IIIT Delhi right now under the same instructor, the Dr. Sarthok Sircar, which is the instructor of this course as well. So this session is basically regarding the doubts any students is having. Since none of the students, we have also shared a Google form with you to share some questions or queries that you guys have. But I have not received any questions on that Google form till yet. And we are going live now. If any students wants to join, then they can join, and I'll be happy to answer any query that they have. So right now, there are no students currently. So let me start by talking about the course, what has been taught in the course in the past 6 or 7 weeks, and what is going to be taught in the next few weeks as well. So as you all know, week one has covered introductory part of this course, how the calculus of variation started, where this is this course born from, and who are the people that those started this course. So this is basically the introductory week. So we talked about the introduction of calculus of variations. Then we talked about the basic Euler-Lagrange equations that we all know. So we talked about the problems that involved calculus of variation or that can be solved by using the tools that calculus of variation gives us. Then we talked about some famous problems that we will tackle in this particular course week by week, and the instructor gave us a brief introduction about every single topic that he is going to talk in the next few weeks. So first of all, he talked about the gold digger problem, the famous gold digger problem, and he told us what is the problem and how can we tackle it using the calculus of variation, and the detailed description is given in the next few weeks content. Then he also talked about the what is the catenary problem, what is the geodesic problem, and how are we going to tackle about the Breakstone problem, Diderot's problem. Also, what how do we use the calculus of variation if we need to find the minimal surface of some figure. And also then he talked about the optimal harvest scheme. Then these are the basic introductory sessions that he gave in the first week. He talked about all these problems. What are these problems? How can we define these problems using the help of calculus of variation tools? And how can we solve them? Then in the next week, in the second week, he talked about some special cases and invariance and existence and uniqueness of solution. If a solution is existing for these particular problems using the help of calculus of variation, then uh, is the problem existing or not? Or if it is existing, is the solution unique or not? That he's going to talk about. So he basically talked about different types of functions. So there are majorly four special cases of functions available in COV. So first function is the function which depends only on y prime. So he talked about the functions that depending on y prime and what will be the Euler-Lagrange equation related to that function, which is a function of y prime only, that is dy over dx only. Then the second case he talked about when we have a function independent of x. That means we have a function f of y comma y prime. In general, we have a function which contains these three variables x, y, and y prime. This is the general equation. But in the special cases, first case we can have when a function depending on only y prime only, and then the second case is when the function is independent of x. That means the function is a function of y and y prime only. Then in the third case, he discussed when a function is independent of y. That means the function is a function of x comma y prime only. And then the fourth case, he talked about the degenerate case. So these are the particular four cases that he taught in the second week. and the Euler-Lagrange equation related to all these courses. What will be the Euler-Lagrange equation and how will it manipulate according to these different categories of special cases. And in the end lectures, he talked about invariance of Euler-Lagrange equation, and then the what is the existence and uniqueness of the solution. What are the criteria that should occur so that a solution exists and it is unique as well. Okay, so there we go with the end of the second week content. Then he talked about in the week 3, he talked about generalization and numerical solution of Euler-Lagrange equations. So how can we solve Euler-Lagrange equation numerically if analytical solution is not possible or it's very complicated to solve? How can we solve it numerically? So firstly, he'll talk about the functions containing different. He talked about different kind of functions. So firstly, he talked about functions containing several dependent variables. That means there are more than one dependent variable. For example, if we talk about a case in 3D, so we have a 3D case and we are talking about the curve that is parameterizing this 3D curve. So we have one position vector RT, that is the dependent variable, and we have different dependent variables in the x direction, y direction, and z direction. So this is the case of function containing several dependent variable. Then he talked about the functions containing two independent variable. Okay, and then he generalized this concept which containing more than two independent variables, and finally he talked about the numerical solution which helped to solve the Euler-Lagrange equation, and he taught us different kinds of numerical methods that we can apply to solve some of the problems which occur in calculus of variation. And the first numerical method that he talked about is Euler's FT method that we can use to solve some problems. The second method that he taught us is the Ridge method, and third one is the Kentrovich method. These three methods he taught us in the third week. With the help of them, we can solve numerically an Euler-Lagrange equation. Okay, so next we can talk about week 4. So in week 4, he's talking about isoparametric problems. What is isoparametric problem, how it is defined, and how we can tackle it and solve it using calculus of variation tools. So firstly, we taught about finite dimensional cases or Lagrange multiplier, which is very useful in these kind of cases. In calculus, Lagrange multiplier method is very common and basic method that we can use in every calculus portion, whether it is multivariate calculus or calculus of variations or anything else. So he taught about this Lagrange multiplier method with single constraint. We can have single constraint since we all know that calculus of variation came from the optimization course. It's a branch of optimization course. So we have some function and we are given with some constraint and we have to solve that function to find its extremum, whether it is minimum or maximum, depending on the problem. We have to find the extrema of that functional, not function, of that functional satisfying those constraints. So we can have single constraint or we can have multiple constraints. So he taught us how to use the Lagrange multiplier method with single constraint, then with multiple constraint, and if we have some abnormal problem, some out of the blue, out of the box problem, then how can we tackle those problems using Lagrange multiplier method? And then he taught us more about the isoparametric problems involving different kind of functions. Okay, so this was the end of week 4. Then in week 5 he taught us about the problem with holonomic and non-holonomic constraints. These are the two different type of constraints that we can get in different problems. So he taught us how to tackle the problem with holonomic constraint and non-holonomic constraint. Then we talked about the problem with variable endpoints, different endpoints. If we don't have fixed endpoints, we have variable endpoints. Then how can we tackle these kind of problems? For example, if we have natural boundary conditions or the famous problem of elastica. So he taught us how to find the solution of elastica using the holonomic, non-holonomic constraint criteria. Okay, so this was the week 5 content. Till now, if I'm correct, week 7 content is live now, and I will tell you the details till week 7, and then I will tell you what are going to be covered in the uh, future weeks. Okay. So in week 6, we talked about the problem with variable endpoints. In the case of several dependent variables or several independent variables, and uh, firstly we talked about variable endpoints in the case of holonomic non-holonomic constraints, but with only one dependent independent variable. Then in week 6 we generalized this case and talked about variable endpoints in the case of several dependent variables. Okay. Then he talked about what is the transversality condition and how it is connected with this uh, variable endpoint situation. Okay. And then he talked about broken extremals, which gives us the famous Weierstrass-Erdmann condition. He talked about what are the broken extremals and how can we tackle them. And then he talks about the Newton's aerodynamic problem, Hamiltonian formulation of Euler-Lagrange equation. These were the topics that were covered in week 6. Okay. Now, then if we talk about week 7, then week 7 taught us about the Hamiltonian formulation. Hamiltonian formulation in the case of several dependent variables. Then he talked about symplectic map. What are the maps and how can we solve them using calculus of variation? Then he taught us how can we reach to Hamilton-Jacobi equation. What is the Hamilton-Jacobi equation? How it is used and how it is beneficial for the problems. He taught us all these things. Then after Hamiltonian-Jacobi equation, he taught us about the method of separation of variables for Hamilton-Jacobi equation. We have all learned about the method of separation of variables in basic PD courses, OD courses, but this is the special method which is particularly designed for Hamilton-Jacobi equation. So these were the topics that he taught in week 7, which is currently live now, whose assignment is due, I guess, on 3rd March or later that, I don't know. Okay, so after that, for the future weeks, for the coming weeks, I can give you a brief headline of what is going to be taught in the future weeks. So in week 8, he will talk about the famous Noether's theorem. What is the Noether's theorem? How it is defined and designed, and how is it beneficial for solving problems using the calculus of variation tools. He will talk about the Noether's theorem, and then he will give an introduction to second variation. What is second variation and how it is defined and used in COV. Okay, this is the brief content that is going to cover in week 8. Then in week 9, he's going to talk about the conjugate points. What is the conjugate points? Then he will talk about Jacobi accessories equation and introduction to optimal control theory, because the course contains the nanomechanics and the optimal control theory, both the parts. So in the previous weeks, the instructor gave us a brief introduction about different problems that is going to cover in calculus of variation course, and how to tackle these problems and what are the different types of functionals that we can uh, that we can handle using the Euler-Lagrange equation, and what will be the Euler-Lagrange for different cases. Then he taught us about the generalization of Euler-Lagrange equation in the case of several dependent variable, in case of several independent variable, in case of single constraint, multiple constraint, abnormal constraint, and different types. So till this week, he taught us the different problems that we can tackle with the different conditions. Okay, and after this, he will talk about what is the optimal control theory, introduction of optimal control theory, and what are the basic concepts that we need to discuss in this topic, optimal control theory, which can be solved with the help of calculus of variation tools. So in week 9, he will talk about introduction to optimal control theory, conjugate points, and Jacobi accessories equation. Okay. After week 9, in week 10, he will talk about about the constraint optimization in optimal control theory. Week 9 will cover the basic introductory part of uh, control theory and the link between control theory and calculus of variation, and the connection how to use the tools of calculus of variation to solve optimal control theory problems. Then in week 10, he will talk in detail about optimal control theory and give you the talk about the constrained optimization. That means we have problems related to control theory and we have some constraint, and how can we optimize this functional and optimize the problem so that we can get our extremum value satisfying those constraints. So it is constraint optimization in optimal control theory that he will talk in week 10. After week 10, in week 11 is basically the introductory part to nanomechanics, since the course covers nanomechanics as well. So as we know that this is a limited week course, so he taught us about the basic introductory part of nanomechanics. How is it related to calculus of variation and how can we solve using calculus of variation tools and Euler-Lagrange equations. He taught us about the nanomechanics portion uh, in the basic conceptual language only in the week 11. So that is the end of this course for week 11. And for week 12, I guess there is some discussion going on and some assignment is given. Some basic important concepts are covered, which are covered in the past few weeks, but they are repeating the concepts so that the students can get a better hand on the subject and on problem solving as well. So this is the basic outline of this course. Now, if there are any students, they can type their questions in chat box. Okay, right now there are no students present. So, okay, this is the basic introductory part that I needed to talk about. Right now, week 7 is live, and I hope you are doing your assignments continuously and on regular basis. And the assignments are really easy if you are easily covering the topic and understanding it properly, going through the instructor's slides and written content and videos day by day, then you can easily solve the assignment problems. And if you have any assignment issue or any problem in solving any assignment question or particularly any solution that you did not understand, you can definitely write it in discussion forum and I'll be happy to answer any of the query that you have. Okay. Okay, Mr. Balaji, are you there? Okay, if any students want to join, then they can. I'll be happy to answer their queries. Otherwise, you can also post your queries on discussion forum and that will be answered. Okay, Mr. Balaji, are you there?
Yes, yeah, we can stop the live, right?
Yeah.